Okay, welcome everyone to a new interpretation and maybe iteration of Hack a Box. This week's Hack a Box, as we said, is going to be a little bit special. It's going to be different because instead of taking a full box and hacking it like we've always done, a walkthrough, what we're going to do is we're going to look at two interesting web challenges, CTF challenges that I've done recently, and we're gonna look at how we can approach them and how we can actually automate them. And these two are little bit advanced, but they're gonna be very, very interesting. The challenges we're looking at today are from this USO Gaming CTF, and let's look at this one. So they're under web. Let's look at these two. So we have one here, which is a profile page. Right now it got 103 solves. People caught on, but it was like around 30 solves yesterday. And we're gonna look at this one as well. Stream VS, which is very interesting again. It has a unique concept and it has 38 solves right now out of maybe 700 plus teams. So I managed to get the two and I found them very, very interesting and unique in concept. I mean, maybe the first one is not that unique. It's and we're gonna see. We don't want to spoil it, but it's a common web application vulnerability. But we're gonna see how we can approach it and how we can find that needle in the haystack. How we can approach the challenge and how can we locate the vulnerability and then exploit it. So let's start. So we have web/profile page. And you can see this first one, it's an open box challenge. You can see the source code. The second one, we're gonna have to do lots of guessing and reverse engineering in the process. So let's do this. I'm gonna open the first link and I'm gonna open the second link. Now for the first link, profile page, we're presented with a login page. We don't know what for yet, but let's see. For the second link, we are presented with an admin bot. So it says admin bot for profile page, and we can submit a URL, and supposedly is going to visit that URL and maybe do something for us. Now, whenever you see, or whenever I see an admin bot, like a reference to a bot of any sorts in a challenge, then I know that there needs to be some sort of cross-site scripting, XSS. Why? Because if an admin is going to visit my page, then probably I need to do something on that page to inject something malicious in it somehow so that I'm able to execute code on the bot's client side. So the bot is going to connect to me or going to visit some page that I control, perhaps, I don't know how, and then he's gonna execute that code by mistake, or that code is gonna execute on his client side or even server side in some challenges, leading to remote code execution. If we are unable to execute code on his server side, at least we can run that on his client side. So I don't know if that's making sense, but if we do xcalidraw, just a quick demo. So we have a bot, so that's the bot, and we have our page. So we have so we have our page here. That's not a page. We have our page here, and that page contains stuff that we control. So we control stuff here, here, here. Now if we can, us as attackers, if we can make this like entice or push this bot into making a request to our page that we control, maybe we can get him to execute code back on his machine. Now this code could take two forms. It could run client side, that's one, or it could run lower down as server side. Now that's rarer, but We could abuse something in between, so we could abuse something uh, in here, so like something here between in the integration between the client side and the server side on his machine, and maybe in his browser. Maybe if it's like a mobile app or Electron app, we can abuse something that can make our client side code somehow execute on his actual system and escape the client sandbox, which is usually done by the browser. If we can't do this, and we only have client side, the ability to execute client side code, then what we can do is we can do plenty of stuff like maybe impersonation, send requests on their behalf, maybe steal something from their client side, maybe like a cookie most usually, so to perform something like session hijacking or session stealing, that kind of thing. So that's a little bit of quick theory behind what we're gonna do. and I know this doesn't make any sense now without the explanation, but yeah, hopefully you got some sort of idea, so we can get started with the actual challenge. Let me copy this code because we're gonna start looking at the code in a second. And let me open a terminal and let's cd into my sandbox, and I'm gonna wget this. Did I not? So let's copy the link and can you zoom in? Sure. Let's actually zoom in before I forget. So we are here, we're zoomed in, and let's actually zoom in here as well. Much better. I think that's better. Okay. Or is it too zoomed in now? I think it's good. It's good. So now this is getting interesting. One of the first and foremost things we need to do is try to use the application as it is intended to be used. So I mean, I'm presented with the login form. Let's try logging in. I'll try my name. Let's actually try my actual name, and let's try something like some random password. We get new user exists with that username. Cool. Let's register one. I'll make one here, and let's try password. Okay. So we're able to register and make an account, and it seems to be a profile page. We're taken to a /profile/ my username here, and I can see some statistics, and I can see some maybe that's like somebody and some random ranking and stuff. Maybe it's like a game profile. Let's actually zoom out a little bit, and here let's see, let's try maybe can I send this, make him visit my profile maybe. Let's submit. What happens? Visit successful. Okay, can we try to make it like visit something else? Okay, so we can literally make it visit anything that we have. Can we see if we can get this bot to maybe visit our own controlled website? Let's actually how can we clear all of these? Delete all the requests. Yes. So webhook site is the site that allows you to create a temporary hook. A hook is just a URL, a unique URL that you can visit, and let's actually come here and visit it. So we have the URL. Now if we visit this URL, then it is going to be automatically caught by the hook, and we can see some of the information. So it's just like an external facing server, nothing fancy, that reads in your requests, and we can use it to quickly test things out and in CTFs, for example, we can use it, as you're going to see, for testing, for example, the admin bot functionality. So right now, when we visited this hook, we received the request here back in the dashboard, and we can see who made this request. We can see the host IP. We can see lots of information about the request that we just sent. But this is not interesting. Let's see, because I made that request. Let's see what happens if the bot visits that request. Okay, we got something here back, and we can see the bot's IP address. Can we see anything else? It seems to be a Chromium browser, so I would say that that makes sense because it's a bot. It's not an actual user, so that's the user agent, or the CHUA. So it's telling us that this is a bot. It's not an actual user, and I think that's Puppeteer or some of these Selenium maybe automated browser libraries. So headless browsers. Okay, so let's see. Let's start moving on to the code. So let's unzip this profile page, cd into it, and let's open this into code. I trust, yes. It's actually code. I mean, how can we? Do we not? Okay. Okay, so we have this here. Let's look at the admin bot first. Let's see what's going on. Okay. One first thing that we want to do is we could follow a reverse approach where we, especially in these white box testing challenges, we look for the flag and see what are the potential ways that this flag could be leaked. Okay. And then from there, we try to make ends meet and try to do something that allows us to expose or exploit or make use of that leaked flag. Okay. So it's like a bidirectional search. We go from the end, from the flag, and like trace backwards, and we go from the capabilities or the input capabilities that we have, and we go forward, and somehow in the middle, if we're able to make them align, we get our flag and solve the challenge. So this is a simple web application. It's Node.js, it seems, and we have a Docker, a very simple Docker container if you want to run this locally, which is sometimes a good idea in these challenges if you don't understand the logic that's going on. We have a couple of views, login, profile, register, nothing fancy. And we have this application. So we have primarily two files, app.js and adminbot_test.js. This is very simple, it seems. It has a function visit URL, and it takes something, it takes a web page, it visits it, and it seems like here, if we look here, it goes to the site, and that site is fixed. It's always the profile page, and then right after this evaluate, it's a special Puppeteer function that allows you to specify some arguments and pass them or like pass them to the JavaScript, to the client side. So that's what we mean when we do evaluate. So basically what this is the equivalent of going to the web page in a browser and then setting a cookie. Okay, setting a cookie, and basically even after you close the page, if you refresh, then the cookie is going to persist because it's the same instance of the page. The cookie is going to persist in that session and is going to be sent again and again to the site. And then after closing, setting that cookie and closing, it goes to some URL that is supplied by the user. Okay, so we have two visits. First, we go to the profile page here, that's fixed, and then we set a cookie. That cookie happens to be our flag. This is the flag here, because down here, yeah, because here we're passing the flag in here, This is the flag. This is of course the test flag. It's not the actual one. Otherwise, that would be too easy. Um, and then after setting the flag, it closes the page and allows you to visit whatever page you're interested in. Okay. So that's interesting. Okay. And of course the cookie is persisted because of this browser. So it is the same browser instance that we're using. It's like we're operating in an actual browser. Same browser instance. We visit a page with it. We add a cookie to one page, and it gets persisted because uh, it's an actual browser. And then if we close the page and reopen it again, then we're gonna have the cookie. So this explains something. When we visited our hook, when we came here and we added our hook, we did not get any cookies because this cookie is set on a specific path. So browsers, that's default browser behavior, and of course that makes sense. If anything else happened, that would be totally absurd. The cookie only gets resent to a specific host or the host it was set at. It's meant for. So the cookie, like no cookie is gonna track you or follow you along all websites you visit. I mean, there's like special tracker cookies, but you need to do some work to get that to happen, to have cross-site cookies, which is also like they're difficult. They're difficult to do. But default behavior is cookies are or correspond to a single website, okay, and they follow you in that website only. A browser is not gonna send the cookie of one website to another website. So what that means is there needs to be a path on this profile page.web-gaming.lol website that allows us, because that's the only website that can read the cookie, that allows us to read in that cookie and steal it. Now, one good thing that we can notice here is, although this is a secure cookie, so this is the way the syntax, you set a cookie, so we're setting a cookie called flag, and we're putting the actual value of the flag, and the path is going to be like any web page on the website, because we can even trigger special cookies that are like more granular and like on single routes, specific routes of a website. But yeah, I mean, most cookies, most general use would be to set the cookie on the entire path of the website. And we have this secure flag, and it doesn't make it that much secure, except it just tells the browser that you don't want to send that cookie unless you are visiting HTTPS, okay? So many people would think that by adding this secure keyword, they're making their cookie unstealable or secure. No, it just means that, or signals to the browser that this cookie is only to be transmitted over HTTPS. And this protects against like network monitoring or network sniffing, so nobody can read the cookie in plain text across the network, which is valid. Now, one thing that's missing though is this HTTPS or HTTP only. Okay. HTTP only is a flag that, when added to a cookie, makes or instructs the browser to only set this cookie in an HTTP context. That means this cookie should not be accessible by client-side JavaScript. It is something to be only dealt with on the HTTP layer. And if any JavaScript on the document tries to access a cookie that is clearly HTTP only, then you shouldn't let it access it. Okay, we should not let that cookie access our we should not let that JavaScript access our cookie. So okay, so we know a couple of things. We know that we can steal the cookie somehow if we're able to first of all, we know that we cannot, so that's like we're doing elimination here. We know that the flag has to come through interaction with the bot. And we know, so maybe we can actually write this. So new file, so facts, And that's it, like a good way to organize your thoughts in these CTF challenges and to eliminate the attack surface. Okay, so let's actually, can we do this? Oops. Okay. Okay, so the facts that we know: flag. So let's make them numbers. So flag is owned by the admin bot. That's important. We need to know where the flag comes from. Admin bot only shares the flag with this page. Okay. So that's important. Now, the flag is shared through a cookie, a secure but JavaScript accessible cookie. No HTTP only. Okay. Let's minimize this actually here. Okay. Can we set for grabbing? Okay, I mean, whatever. Okay. We're making these assumptions, which is a little bit slow because you're not doing code, but these dictate your methodology. These dictate how you think, how you approach the challenge in a way that prevents you from straying off and like diverging and wasting lots of time. Because it sets the ground rules for whatever is going to come. The flag is shared through a secure but JavaScript accessible cookie. So what this means, what all these 3 points tell me is, if we are able to execute JavaScript on a profile page website, we can somehow steal the cookie. Okay. But the issue is, this profile page is not controlled by us. It's some website that's made by someone else and we have no control over it. Okay? Unless we do. So there is, like, now we boiled it down to one thing. There has to be a way on this website that allows us to inject malicious JavaScript code, somehow modify the website so that when the bot visits it, we can execute our JavaScript code and execute and steal the cookie. Is this clear so far? Excellent. Now let's move on to the next step. So we have this application, and let's keep the facts here. We're speaking facts here, and here we have the source code. So let's look at this. So we have a couple of things. Let's look at this quickly. So we have a profile page. We have it requires login, of course, and if you log in, it takes you to the username. There's okay, there's a page / profile / user. So if we can like come here, let's like try to map this to. So if we have something like anything here, no user exists with that username, which is given to us here. So we try to map the actual application functionality to the source code that we're seeing. Login, register, we use these. There's something interesting here. I'm going to look at that in a second. And there is a login functionality. There is registration, and there is a cookie CSRF, and we'll see what that means in a second. And there is some interesting filtering mechanism going here in a second. So we said that we do a reverse lookup, so like reverse from flag to uh, like that's one direction, and then goal, and then the other way around. So maybe like the flag is here, input. So we take the flag, we move backwards and see what can we do, and we look at the input and see what can we do, and somewhere in the middle we reach our goal. So we took the flag to the max, or like the end goal. We took it all the way to here. We like through these steps. We said that the flag can be like taken all the way to, if we get the admin bot to visit our page, and we're able to control not our page but this special page, profile page, and we're able to control this profile page somehow, then we are good. We're able to execute some JavaScript somehow on the target and reach our goal. So let's see what embed allows us to do this. So what thing that, because embed is the only way you can interact with the website. So actually here our target is going to be profile page.web. The website. So that's our target, because that's the target, that's the middle thing that the admin bot can visit, and the middle thing that we hopefully can use our input to control. So let's go down here and look for ways we can modify things. So, or like we can inject input to that web page. So there is registration. So when we register, we modify something in the website database. That is like we add a new user. So maybe like we can inject our username. Let's see if we can, if that's valid. So it checks if we have a username, a password. It checks for the, it makes sure that the password is more than at least 8 characters, and the username is at least 5 characters. Cool. And then there is another check which says that the username cannot be cannot have any characters other than these. So it can only have A to Z, capital A to Z small, that's regex, and 0 to 9, and space characters. And it shouldn't be more than 30 characters long. Oh, so that's difficult. Like if we're to bypass this, it's gonna be a little bit difficult, and I don't think we can like fit any code in that amount, you know. So I think I'm gonna exclude this, even though that's a legitimate input that we can control on the website, but it's too restricted for our needs. Let's see, user has your name. Okay, let's go down here. There seems to be some CSR, like cross-site request forgery mechanism here, token, that is being added to each page you visit. So it's added here as well in the login, as to prevent like automation. It's done in a like inefficient way, but that's what they meant this for. It is to prevent automation. So like it's a unique token that gets sent when you log in or when you register. Ideally, it should be sent with every page that you visit. So like when you visit a page in a browser, you need to maybe do a GET request first to see the web page before you post something. And that slows down automation to an extent. It's bypassable, but it can be annoying. And but here they just issue one CSRF cookie per login attempt and per registration attempt. So it persists. You don't need to bypass it really. And oh, now this is the interesting part. There seems to be some route that allows us to update our bio from the UI. Okay, it allows us to update our bio, and you know, when I see this, I'm like, خلاص, I'm fixated on this. I think this is gonna be too good. We have a bio that cannot exceed 2048. That's plenty for me. I think if we somehow bypass whatever protections there is, then this is gonna be good. It checks for the CSRF token. It makes sure that it is there and it is valid. And there's a couple of stuff that it does as well. But one interesting thing is the bio before getting updated, before getting set, we go through this render bio thingy here. So let's go to render bio and see what that is. So if we go up here, here we go. That's, first of all, let's see where does the bio get stored. So we go all the way, or like get presented to us. Where is it? If we go to /profile/user here, we see that we do render profile. And if we look at the profile, like we're tracing the bio now to see where it ends. If we go to profile, we should see, okay, it renders the profile, the username. We can look for bio, and here we go. So it renders the user bio within the template. Okay. And I think so handlebars, I think this is special because let's copy this. So JavaScript handlebars. Let's actually look at the documentation. So language guide, and let's see, so maybe something like this. Okay, here we go. HTML escaping because it was originally designed to generate HTML. Handlebars escape returned by expression. Okay, if you don't want handlebars to escape a value, use a triple slash. This triple slash. So if you want things to be presented raw here, oops. So like in this example, you do triple curly braces, and they're gonna be spit on the page as is. If you do just two, by default, this safe way is gonna be escaped safely as HTML and ampersand sequences. Okay, which have no meaning. I mean, they're just like they don't represent any valid HTML like properties. They're just plain text. So we know that this is vulnerable. Okay, three stash is vulnerable. Okay, so we know that. So now we're making points on the input side. So bio rendered in a vulnerable way. So you should never use something like this on unsanitized input, or input that you know may be insecure or controlled by the user. So this is not completely insecure yet. We need to see how this user.bio sanitized, or whether it is or not. So let's look at this. We know that it goes through, it gets rendered and gets presented to the user, whatever. Best locals users. Okay. Okay, let's look at how it is, or how this render function is implemented, render bio. So it takes in the data that is given to it, and it calls some function called render bb code that takes in like tags like this. So let's have a demonstration of this. But it takes it and does apply some rendering function to it, and then it calls DOM-Purify, which is a very popular anti-XSS or XSS sanitization library, which is very well tested and pretty much secure. And it sanitizes that HTML, and then it does something really interesting. It says, we'll do this after sanitization because otherwise iframes would be removed. So it wants people to be able to send YouTube links, so it replaces these YouTube BB codes, and we can talk about BB codes in a second. It replaces them with an iframe. Now there is a more secure way to do this by just while calling DOM-Purify, we could like send some configuration. I'm not sure what is the exact syntax, but you can You can configure, I think set config, yeah, but you can configure DOM verify to allow iframes that has YouTube a YouTube source on them. So DOM verify can do this instead of you having to do it manually and potentially subjecting yourself to vulnerabilities, which we're gonna look at in a second. I know we're slowly building up to the topic, but that's precisely the way we want it to be. We want to be sharing the mindset and the thought process behind this kind of challenges. So let's actually do something here. I'm going to create a new terminal because I want to write a BOC or a proof of concept solving script for this. So let's cd into sandbox, and let's use code as well, could we? Or we can do it here, right? We can do it here. So let's do new file, solve.py, and this is going to be our solver script. Okay. Okay. Can you see the font? See the font? Let me actually type something. Is it clear? Import requests. Okay. So now that we have this here, let's try and maybe simulate a login. Okay. So I'm gonna do something like this. I'm gonna first create a session, and I'm gonna call this requests.session. Okay, and don't we have some import? For some reason we don't have any Python auto-completion, but that's fine. So we're creating a session so we can persist some of the cookies and the things that are getting sent to us. And make the font, okay. Oops. Can we preferences, settings? Better? Okay. So we're gonna create a session, and I want to simulate a login, the first thing that I want to do. So let's do S. So now S represents our session object, like our request session, HTTP request session. So it maintains cookies, it maintains lots of things. And I'm gonna do post. I want to log in first. I want to just test something now. So I'm gonna do so where's the API login? It takes a username and a password. So I'm gonna do, let's have a URL here. That's gonna be our base URL for this challenge. So now we have the URL, and we can do simply something like this, URL, and we're gonna go to /API/ oops, not here. So here, URL /API/login, and we're gonna pass in some data, and that data is gonna be a username, which is gonna be my name, the account I just made, and a password, which is gonna be the literal word password. And we can make this here, I believe. Okay, maybe organize it a bit. Okay, so, and we can look at the response. So I can do something like r equals store this, and I can do print r.text, and maybe I can print as well, print the cookies I received. So I can print session.cookies. Okay, now can we run this? I can do python solve.py and see what we get. Okay, so we seem to get some stuff. So we did actually log in. I would believe that this is the profile page. Yes, it is the profile page. It has my username in it. And if we go all the way down here, we can see the cookies that are in the session right now. So it says there is this cookie CSRF, and it is that long, and it belongs to profile page web.usugaming.lol. So it is associated with that. So let's get back to our code. And what we want to do is we want to see if we can update our bio, because it seems like there is no. So if we do bio, yes. So it seems like there's no UI for this yet. So we can't actually handle this from here. There's no option, but the feature is implemented. So many times when you're testing web applications, you might come across unimplemented features that are not part of the UI yet, but they are implemented in the backend. So they're available as an API endpoint. So let's hit that route. So it's /API/update, and it takes in a parameter called bio. So let's try this. So I'm going to do r equal. So that's another request. s.post. Actually, I don't need. No, we can keep it. It's going to be s post, and it's going to be the same thing again. And we're going to hit /API/update, and the data is going to be /bio, bio, and let's try stuff. So let's try hello, this is my bio. Okay, and we want to see, we can do this in the browser. So I can do this, run this script, the CSRF. Let's see what happens. If we refresh, I think nothing will happen. Yes, nothing happened. Let's see why. If we do here print r.text, so we want to look at the response and run this again and refresh. Let's see what happens. So that's the response that we received, missing CSRF token. So if we look back at the code, so apparently this CSRF token is doing some kind of protection here, and it's being mildly annoying. Let's see. So if you look at the app, how can we trigger this missing CSRF token? If our request header does not have a CSRF token. And before we move forward, let's check the other condition, because there's another condition related to this. The header CSRF token must be equal to the request CSRF token. Okay, so we need to set this header to equal this cookie. This cookie, this CSRF cookie is getting passed automatically because we're using a session. So because we're using a session, the cookie that we received when we logged in is getting passed to every subsequent request, but it's not being passed in the header. So we need to do this manually. So if we go to the solve.py, let's now, from now on, let's grab the CSRF cookie. So if we can do s.cookies CSRF, that's going to be our CSRF, the token. Okay, and let's actually try to print it, CSRF token. And if we solve this, here's the token, so we can see it. Now let's try something else. I'm not sure. I think this connect SID that's done by HTTP, by Express session, is something else. It's something to identify us uniquely across sessions, so we don't need to worry about that across requests. So let's pass this cookie in the headers as well. So what I'm going to do is I'm going to do s.headers.update, and I'm going to pass in this CSRF. So I'm going to do CSRF, and I'm going to pass in my CSRF token here, and let's hope that this is the right way to do it. Let's actually have a look at the headers, session headers, and let's have a look at the response after we do that. So if we run this again, boom. So this is the updated headers, of the requests that we do. Every request in the session is going to have this same header. It has the user agent Python requests, and it has the updated CSRF token added to it. And because of that, because of the updated headers in our session, we were able to execute the bio update functionality. Now, I think even just this bit, we're already learning. Like, even though we're not solving anything, we're already learning how to deal with requests, how to automate sessions, how to basically manipulate everything in the HTTP process to our advantage. So let's actually keep this here, and let's move on to the next step. Now we're able to set the bio. It said updated, bio updated. So let's see if we can. I don't want to look at this anymore, but let's see if we refresh this. Oh, we successfully updated the bio. So now that we've done this, let's test the functionality we've seen earlier, the BB code functionality, because it seems that this bio, before it gets rendered, before it gets updated, it goes through some filter or like rendering process, string manipulation process. If we look at up here, it seems to be for convenience. BB codes are, if you've been part of the old forums where you could do something like bracket B bracket, and then it's gonna swap these with the actual HTML elements. So if we go back to our code, solve script, and let's add something like new line maybe, and then we can do this is bold text, and we can do this. That's a BB code, and if we run this, and if we refresh, we can see, I don't know if you can see it, but this text is now bold. So it's triggering the BB code. See, the BB code format is getting triggered, and it's replacing this, if we look here, with actual HTML tags, strong and strong. Okay, interesting. Now, could I possibly abuse this? Could I possibly make use of this? Now, it's very much looking for anything that starts with it. It's actually backslashing, so it's escaping the brackets here, because these are special regex characters, and in this context we want to interpret them literally. Okay, they're literal open bracket, and it's literal close bracket, what is it called, rectangular bracket. And it's using a capturing group here, using these parentheses to gather whatever is inside and like assign it to position 1, and that way we can grab whatever is within this and replace it and put it within strong tags. So personally, I don't see any way we can abuse this, because no matter what text or payload we put in here, okay, that gets placed within this, it is going to go to the next step, the purify.sanitize.html, which is pretty much, that's XSS destroyer. This is gonna like destroy whatever payload you throw at it, unless you're looking for some novel 0-day in some very well tested library like DOM Purify, which had its share of XSS vulnerabilities. I mean, obviously, as an anti-XSS library, but I don't think that's the scope of this challenge. That's something very advanced. And one thing that I did check was, when we look at the package JSON, we can simply take this package and go here and do something like npm and paste that, and we can have a look at the version number of the current version number of DOM Purify, the package 3.0.9, which is here, 3.0.9. So we're running the latest DOM Purify. It's not one that's susceptible to any XSS. Sometimes a challenge would have that would be the trick, that you're meant to use the package version numbers to look for or to use a proof of concept written by someone else to bypass that package. But here what, like, instead of all of this, what I can look at is something very interesting, something that totally bypasses or like comes after the sanitization process. It looks a little bit secure, but let's see what's happening. So if you supply a YouTube tag, okay, if you supply a YouTube tag, you're able to control whatever is within is going to be like the YouTube ID is going to be added into this. Okay. So let's see how that goes. So I'm gonna do some testing here. Sorry, and let's try that YouTube thingy. So I'm gonna do YouTube, and the BB code for YouTube, and I'm gonna add some. Maybe I don't have a YouTube ID on me, but you can see the concept. So let's save this and run it. And if we get updated, if we refresh this, we can see that there is a YouTube iframe in here. Now it's not working because I didn't supply a correct ID. But if we look at the inspector, it's important to look at the inspector to see what's actually going on. We can see that there is an iframe here and 1, 2, 3. Okay, that's the input that we've added. And if we edit this actually as HTML, let me copy this because we're gonna look at this in a second. And it is just replacing whatever is within this capture group into the source tag. And I think this is a very interesting point, because now we've boiled everything down to this injection point. That's one point where we're doing a string replace, and we could somehow, I believe, abuse it. So let me do this. I'm going to okay, let's have this. So this is our, let's actually break it into, okay, so this is the first part, and then comes our payload. So payload, because that's it, like after this we're like comes, let's actually call it like just this. So after this / comes our payload, and then comes a double quote, and then the rest of the iframe, and we have complete control over this point. If you look here, anything that is within this area is going to be moved into this injection point, this replacement. So can you see it? Can you see what we're supposed to do? Okay, so it seems Omar has gotten it. Nice, nice. So since we have someone who got it, let's actually move quickly and show you how he did it. So this is gonna be equal to, so our payload is gonna be whatever is within YouTube. So let's actually match it. So this is the payload. Let's actually create a Python variable. So I'm going to call this payload, and it's going to be equal to our payload. So whatever payloads we're going to have. And before we send it over, we're going to wrap it with YouTube. And we're going to add our payload here, and we're going to pass. So just a for convenience, we have the whatever we have in the payload concatenated with the open tags, because that's a condition that executes this dangerous replacement, insecure replacement. And this is going to take in our payload, and let's formulate the actual payload. So our payload, I think what we need to do first of all is we can supply anything here, it doesn't matter. So like after this, and then we're going to do double quote to close it, and then we're going to do space, and then we're going to do something like, there's a couple of ways we can do this, but what we can do is we can do I believe onload. That's one of the I mean most straightforward, and I can do something like this. So console, or let's do alert. Oops, onload alert 1, and this syntax in JavaScript allows you to just like, it's shortcut for braces, double quote, and then 1. Okay, so it executes the function and passes it a string. So we have this on load, and then we need to escape this because we have a couple of things coming after. So we can do maybe something like, I don't know, so we can have some, or actually we don't need the trailing double quote here because we're going to get it from this one. And yeah, I think that's pretty much it, is it? So let's copy this, and it's going to be within our payload, and make sure we're enclosing it in single quotes, because within we're using double quotes. And here we're using these ticks because we don't want to confuse HTML. I don't know if it's going to work, but we don't want to confuse HTML with the HTML double quote with this what's going within. So now I believe if we do python solve.py here, bio updated. Now if we come here and refresh, I believe to see, yes, here we go. And this is proof that we were able to execute or abuse this vulnerability to execute JavaScript code on the client side. Now we executed that client side on our machine, and the rest I think is very easy. We can just simply get some code that can request this page. So actually it's not totally easy, but like we need to do some exfiltration, okay, to exfiltrate the client cookie. So this is innocent payload. Now let's have the malicious. Oops. This is just proof of concept. Now let's have the weaponized payload. So it's going to be payload, and it's going to be 1, 2, 3 onload equal to, and we're going to do fetch, and our fetch is going to take in our webhook, okay, URL, and let's actually build it. So let's build it like one step at a time. So payload plus equal, and it's going to have our website, and we're going to do payload plus equal, and we're going to have to close this, and let's actually do parentheses here because we're going to do some concatenation. And now that we've added this, let's concatenate something interesting. Let's actually add a slash here, / because we're going to request something on that. That's how we're going to exfiltrate the cookie. I'm going to use binary or byte to ASCII, and I'm going to do document.cookie. Okay, so we're going to see. And let's see, this is correct, this is correct, this is correct. I believe this is the correct payload. Now, if we are to run this and come back here and refresh this, I should receive something here on my webhooks, yes, but this is not going to be the actual thing because that's going to be my own cookie. Okay, so that's my own cookie from my browser because I visited it. And the way we can let's zoom in here. The way we can extract that is we can do reverse the B2A. We did B2A to exfiltrate the cookie. B2A takes a string and converts it to base64 for proper encoding across like a URL safe encoding. Now if we want to do the opposite, so A to B, and I can paste in that, which I copied from the URL here, and enter, and we can see the cookie that was passed on by my client, which is the CSRF cookie. Okay, that's the only cookie I have. I don't have a flag cookie, but maybe someone else has a flag cookie, and that is the admin. So I can take my profile page is now malicious. Like anyone who visits this page on this website, he's gonna get his cookies stolen. And that's critical. That's like really dangerous. Like I could, if this was found in an actual website, I can share a link, maybe like a Facebook. If Facebook had this, this is an instance of stored XSS because the cross-site scripting payload that we've added is being stored in a web page and is being served to every single person who visits that page, which is dangerous, very, very dangerous. One of the most dangerous types of XSS because it's persistent and because it doesn't, like the payload is in the page itself, like the URL looks safe, it's secure, like there's nothing suspicious here, maybe like some URL parameters with the payload in them. No, it's a legitimate page that I just visit as a normal user. But if I happen to be logged in on this website while visiting this page, then I'm gonna get hacked or get my session hijacked. So let's come here and make the bot visit our innocent profile page. Maybe he wants to look at it. We submit that. Let's see. And boom, it goes to 2. Now this is ours because we just visited the page, and this is from the bot. We can do this, select this here. There's better ways to pass this on, but I mean, I don't mind. And what we can do is come here and do ASCII to byte again and paste this and enter. Here we go. Boom. We got our cookie flag, and that's our flag here. I enjoyed it. I think this was very interesting. XSS is one of my favorite kinds of challenges because there's so many moving components, so many things that you need to do. So first of all, actually getting the injection, so bypassing sanitizations, bypassing the filters, and then there's a little bit of networking. So like you have to know who is talking to who, and you need to get that right. The exfiltration, you need to make sure that you're able to take the right thing. Maybe there's no cookie, maybe there's some element on the admin's profile that you're trying to steal. We could do that as well. So there's so many moving parts, and when you add more safeguards and more controls, it gets very, very, very interesting. I think it's easily my favorite web vulnerability and favorite type of challenges, web security challenges. So yeah, that was it. We were a little bit overdue. We started late, but yeah, I hope you enjoyed it. Hope you learned something, and see you in the next one.